All right. Thank you so much, amazing speakers tonight. I would like to introduce we're going to do a deep dive into decentralized confidential computing. And I will introduce our moderator now, who is Zoe McFox, the VP of Business Development at Fala.
And yeah, I would like to invite my panelists. I think we might also need another chair, because we have a big panel. We have Alex from Secret Network, we have Yannick from Akim, sorry. Artyom, there it is. He's new to the panel, that's why. So apologize, Yannick. Marvin from Fala and Guy from Phoenix, I think. And then we have also Bowen here. Yes, please join us as well. Do we have enough chairs? Guy, Yannick, Marvin, Bowen. Alex, you're not on the panel? Okay. And we have one microphone for the speakers. Okay, that's great. Cool. Yeah, thank you everyone for joining. This is our third DCC day, right? Yeah, very cool. Thank you for pulling it off again to the Secret team. Fala is also a main sponsor, and we are working closely with the Secret team to create these events. We have done this deep dive panel also in Austin with similar speaker constellation. We had Hang last time from Fala, now we have Marvin here, co-founder of Fala, and Yannick also is the new addition. But I would like to switch it up, of course, a little bit, but the topic is the same, deep dive into DCC. And if you guys would like to introduce, how do you tackle or how do you provide decentralized confidential compute with the technology that, or the product that you work on with the technology? And I know we have a mix of technologies here, some of them using fully homomorphic encryption to provide confidential compute. We have trusted execution environments or multi-prover computation. Guy, if you just want to give a quick overview how Phoenix tackles DCC.
And happy to be here. Thanks for inviting us. And thanks. I think so. So, Guy Tzraki, I'm the CEO of Phoenix. As you can tell by the name, we're utilizing a very novel encryption technology called fully homomorphic encryption to tackle the problem that we think is the next problem to be solved in the blockchain space, which is lack of data confidentiality. Fully homomorphic encryption is a very novel encryption scheme that enables you to run computation on data while the data is encrypted. We're building an L2 on top of the Arbitrum stack, and we can talk a bit more about how we think this interconnects with the other projects here.
Yeah, I'm happy to be on this panel. I'm Yannick. I'm the CEO and co-founder at Arcium. And what we are doing at Arcium is we are building a confidential computing network that currently mainly utilizes secure multi-party computations as the core technology for achieving this confidentiality. And what really drives us is similar to what Guy described. On the one hand, bringing confidentiality to the blockchain space, bringing confidentiality to on-chain applications, and allowing both entities and individuals to gain privacy and confidentiality for all of their interactions. But what we find very important, secondly, and that also ties into the architectural design of us being this stateless, fully focused on computations network, is that blockchains combined with MPC allow for a completely new notion of decentralization and trustlessness, which allows for far better confidential computations than what has previously been possible in the traditional confidential computing space, because there's also a traditional confidential computing space, the CC space, I guess, and we really built out a DCC space, bringing something completely new. So that's really what excites us, is that those use cases can now be brought into those new trustless, transparent architectures.
Yeah, hi everyone. This is Marvin. I'm the co-founder and CEO of Fala Network for the company behind Fala. Fala is the DAO. And what we've been building is decentralized compute network that can provide verifiable compute. So we are talking a lot of TE coprocessors today because coprocessor is more like a use case or like a tool that how can people actually use TE networks. The trust assumption of Fala Network is that we don't trust in single TE. Like we think like single TE hardware trust assumption is just weak. So we need to add up some lockup or some security enhancement on top of it. So this is why Fala exists, so that the people who want to use TE for blockchain technology, they don't need to trust Intel SGX or just trust a single hardware. The trust assumption is something far more beyond that. So this is what we've been doing. Yeah.
I'm Bowen, co-founder at Fairblock. We see ourselves as like an encryption service provider. So we use threshold identity-based encryption to enable what we call like pre-execution privacy, so that transactions in the mempool can't get reordered. And you can also use it for cool things like scheduling transactions, and it's, I guess, a form of witness encryption. We use MPC in the sense that we have a decentralized validator set of networks, which like a threshold doesn't need to work together in order to generate this decryption key, and that's something really important for decentralization, especially you don't want just one party to hold a decryption key, otherwise that would sort of make this whole thing pointless. Yeah.
Cool. So maybe I think some people in the audience now think, cool, you all do confidential compute. So you all provide the same, but no, not really, because you all do it with a different technology, right? Fala, for example, focusing on the hardware side, TE. Then we have FHE, which is the verification on-chain, or MPC as well, right? But Marvin, if you want to say, why did we choose TE for Fala, and maybe what are we working on to maybe add different technologies to it as well?
Yeah, so like in 2018, there's a paper presented, I think, by Dr. Dong Song, right? Like the ETH network solution. So we saw that, and I think using hardwares, which is already like even in 2018, it's already a 10 years old technology, and all of the security labs in the world is just attacking the system every day to find some bugs, to find some problem. So we think it's a very mutual system that already under tested and being improved every day. So that's a very practical solution if you want to have something right away, you know, to do the jobs that blockchain can barely do, or expand the block space for other smart contract virtual machines. So this is exactly why we choose TE, like to provide a high performance, high low latency, full functionality service that you can do a lot of jobs in off-chain, but in the meanwhile keep trustless, keep verifiable. But of course, we also know all of the problems, right? The issues. There are bugs, hardware could be attacked, there could be a single point failure. It's very hard to share state between these confidential enclaves. All of these problems exist even today. So this is why where we, not just us, right? Also Secret Network, Oasis, Automata, we begin to use the technology of blockchain to kind of expand the weakness of, or improve the weakness of a single TE system. So a common misunderstanding of TE is that it's hardware, right? It's just hardware. So if the hardware have a weakness, you're fucked up. It's not, guys. Like TE is a systematic work. It's a system. It's not hardware. It's a system based on some trust assumption for these hardwares. So if you're not happy with the trust assumption, you can build a system with much more security, much higher level of original security assumptions. So this is how we bring other technology like FHE and PC into together for the confidential computation. Yeah.
Bowen, do you want to focus on why you chose the MPC approach for DCC?
I think we wanted to focus on something that's practical and available today. So our solution is pretty lightweight, I would say, and it offers like a seamless user experience. So user encrypts in browser in like milliseconds, commits it on-chain, and then the decryption is pretty quick as well. And it could be integrated to a lot of existing ecosystems. So we thought that was like the main value proposition of choosing our approach instead of like having to source applications and developers and liquidity. We can just provide this service to existing networks where they would need this service.
Okay. And Guy, question to you, because you have a long experience working with TE. You worked at Intel, right? Now you switched to Phoenix, which is mainly leveraging FHE, which is powered by MPC. Why do you think FHE is the best technology for DCC?
Yeah, I actually used to be on the TE camp. I used to go and promote TEs, and I think TEs are great, to be honest. I think they're amazing. It actually starts with, before talking about the technology, about the problem, right? We wanted to make sure that we're providing capabilities to this ecosystem that are just a fundamental key. If you think about companies that want to pay employees with tokens, they cannot do it without any level of confidentiality. Like underlying confidentiality is a building block that's missing today. The second part was we wanted to make sure that we make it as easy as possible for developers. So we picked the Ethereum ecosystem and we went with Solidity, which is where most of the developers are there. And then you have the part when you need to decide over the technologies. My personal opinion on TEs is that they're very, very valuable. They can scale very, very fast. But many of the users prefer cryptography-based security, which is where FHE excels. And then there's always the debate between FHE and MPC. Would love to hear the MPC's feedback here, but my personal opinion is MPC is still very communication-bound and cannot scale very, very well when you have multiple nodes. But I guess the guys here will probably not agree with me. Where, for me, FHE is the end game because it gives you computation on very encrypted data. It's actually the end game is a combination of all of them. It's FHE, MPC, TE, and zero knowledge, which we don't have here. But if anybody from the MPC side wants to.
Yeah, would be a question
sure,
to you, Yannick. Please comment.
I think for us, why we chose MPC really boils down to practical solutions that match trust requirements that we see in FHE systems, for example. So if we are simply running FHE, we see operations over an encrypted representation of data that gets mapped in another encrypted representation, right? And so if you want to see selective disclosure of that data, you need some way to decrypt that data in a decentralized way, right? And so that's where secure multi-party computations come into play. And then we see the usage of the exactly same trust requirements. And so for MPC, there are trust requirements. But our approach really was bringing the trust requirements down as much as possible so that they become fully reasonable trust requirements. In our case, that means dishonest majority as a trust requirement. So in any set of nodes running a computation at Archium, you only require a single honest player, a single player that is not collaborating with the others to undermine the confidentiality. And previously, in the history of multi-party computations, those kind of dishonest majority protocols have been less efficient, which is just logical if you think of honest majority as a trust requirement versus trust requiring a single one. So there's cryptographic overhead and communicative overhead associated with that. And the way we were able to tackle that and bring down the operational cost very close to the actual plain text operational cost is by recent breakthroughs in the pre-processing MPC model ecosystem. And with those pre-processing protocols, we are able to achieve this very high throughput, very fast operations, and that's very significant. Because at the end of the day, for users, for applications and companies to adapt in technology, to introduce confidentiality, introduce privacy, you can't force them to work with those kinds of significant computational and cost overheads that go into many orders of magnitude. So for us, it was important to bring that down as much as possible, to have a solution that people can work with, that allows people to have the smallest trust requirement possible, and yeah, this practical approach.
Guy, do you want to comment on this, or next question?
No, just to say that it's never, for me, it's never about is FHE better than MPC, is DE better than FHE. We're still a small market. We need to grow this market. We need to make sure that people understand that there is a huge opportunity here. I know we have a question on AI, which we're going to get into in a minute.
But maybe after our last event also, we actually had like a use case discussion between Phoenix and Fala. Do you want to touch base a bit on this, like what we are exploring to combine TE with FHE?
Clearly, as an FHE network, there is a need to decrypt the data. There is a need for the ability to have a combination of multi-party computation that enables you to take the decryption key and split it among different nodes. This is an area where Phoenix and Fala are now looking into partnering with. I would say, in general, there is a very big opportunity coming upon us with encryption and privacy, at least as my personal belief. I believe that this ecosystem has done a phenomenal job in reducing cost. Blockchain in general has done a phenomenal job in scaling. And now the next focus in the next couple of years is really going to be about how do we provide new use cases that you just couldn't do before without data confidentiality. You just can't. And that's where all these companies are actually going to be dealing with.
Let's talk about the use cases. I just moderated another panel at the Open AGI Summit, which was actually about ownership and privacy, where we discussed several technologies that we are building here. So Marvin, Fala is also focusing a lot on the AI use cases. Why do we need DCC for AI, and specifically what is Fala providing for this space?
It's time. So, it's time, yeah. So, but yeah, I'll try to keep it brief. I think we are losing time. Yeah, so I think it's a crazy idea to combine AI with blockchain. But it turns out there's so many VCs love this idea, and there's so many projects building AI with Web3. And guess what? Vitalik loved that idea. So I guess that's the future, because blockchain have a reputation of bad user experience, right? It's fucking hard to use, sorry, it's on record. So it's really hard to for retail user to understand what's the best way to interact. Download MetaMask, Phantom, and use that chain, bridge that. So we have the worst experience in the world, and I think AI can solve that problem, because this is the best expertise of AI, that they can solve complexity jobs based on very simple input and demand. So the problem is when AI becomes the major interface between retail user and blockchain, there's a middleman, right? But it's against the nature of Web3 native people. We hate middlemen. We don't trust a lot of stuff. How to remove, but we have to use AI as interface, as a middleman. So how we can live together. I guess you can't run LangChain SDK on any Ethereum capability like blockchains. You can't use AutoGPT, run it on blockchains. So we have to use them. So the point is, if we have to, what's the best way, right? Like, just imagine a use case. I will try to keep it brief, right? So when AI become our interface, it basically replacing our daily using wallets. You are depositing money into this smart wallet and tell the agent, hey, do this for me, do that for me. When something happened, when you deposit your money to it, you want to know exactly how it deal with it. You want to know how the transactions be made. Is it really executing the job that model tell the backend of this agent, right? Is the RPC, made in time, this and that. So things could happen, and in that perspective, I think confidential computation is the only way that we can implement AI interface inference models, big data as a middleman. Yeah. So
Right.
this is why we are here. Yeah.
Very good. And I didn't want to turn this into an AI-focused panel, but I mean, it is a very big use case, especially for DCC. Yannick, do you want to comment on AI specifically or other use cases that you enable with MPC?
Yes, definitely. So I think what multi-party computations already from the terminologically itself gives us is multiple parties having data that collectively could be utilized to train models, but for different kinds of reasons, for regulatory reasons, or simply the sensitivity of that data cannot be shared. And so what's possible with what we're building is essentially trustless federated learning. Be able, as multiple parties, to use the union of all of your data sets collectively to train a model, and then be able to utilize that model. So in healthcare, that's very, very important, because there's those very isolated, sensitive data silos that now can be combined. And with those trustless, decentralized environments, it's even possible to have those models remain fully private, fully encrypted, and then inference and prediction on top of those models can also be confidential. So it's a fully confidential chain from the original data owners to the end user that receives the prediction, with no middleman in between, no trust required. And so I think that's very significant. Besides this notion of setting up agents, I think data ownership is really what it's about in this
Very
time.
good. Thank you. We are over time, but I would like to have Bowen and Guy also comment on this. Maybe the next big use case for DCC, or specifically MPC besides AI. What's your take?
Yeah, I think gaming, social are probably two sectors where there's a lot of opportunity. Like gaming, some sort of like loot box style, like you need on-chain randomness, which our technology provides. Social, I don't think people are comfortable broadcasting all their messages fully on-chain in plain text. Some level of encryption there is necessary. Yeah.
And Guy, the last word for you. What is the big use case for FHE?
To be honest, I
Tricky
think
now.
we're all looking for the next big use cases. There is a lot to be done. We haven't yet figured out where this will go in the next couple of years. But I will say, since we talked about AI, that AI is about data. You train data, you use data, you request data. If you don't have a mechanism that enables you to trust whether the computation was done on the right data set, whether you got the right data set to begin with for training, then you're just trusting somebody, which is not really where we want to be. That's it.
Okay. I think that's it for the panel. Thank you so much. We learned a lot how to combine all the technologies we're working on, big use cases, AI and gaming. And the speakers are around for more questions. Thank you.
Thanks.